Hello and welcome. Today is Monday, August 24th. Happy Kobe Bryant Day. Today we pick back up with the new business school and we are building a curriculum on an intro to AI agents for business. Our capstone for this class, as I've mentioned before, the capstone will be capstone. We are going to try to build an agent that will make $100 per day per person. That is the capstone project that we are building to. We'll talk about that a little bit more like as we go through. Today's case study, I will tell you how I won the NVIDIA NYC Hackathon over the weekend. 40 teams from around the country flew in to participate. There were more than 300 participants, 40 teams, and my team walked out as the winner. And what enabled us to win was not advanced technology. The teams that used Claude Code, many of them did not rank at all. Why would the teams that used Claude Code not even rank? This is because of two big things that they're missing. Number one, they don't understand calculus. They may have taken the class, but they don't know how to apply the concept of understanding the rate of change and impact to time, cost, and risk. As a result, you're going to lose because you don't know what to prioritize. Number two is data literacy. When your data doesn't have integrity, when you do not understand the lineage of your data as well, and when you just are very willy-nilly with your data, you're going to lose in all things software. Today, what I will do is, despite the fact that I'm talking about calculus and I'm also talking about machine learning specifically for big data, I want to mention why the most important thing for data literacy will be our imagination. In the previous lecture, what I talked about with data literacy was I said there's three questions that are worth answering. These three questions are: what is data? Why does data matter so much? And why are humans controlled by data? In the previous lecture, I mentioned that this follows the principles of, not the principles necessarily, but these follow the ideas of Immanuel Kant. Immanuel Kant is a German philosopher, and he thought quite deeply about a concept of the noumena, the thing of itself, and phenomena. Big data and all data is phenomena. It are things that humans can observe. However, we use big data to make predictions. Humans don't know how to predict. Only the universe or the Godhead would be able to predict. And so now we enter into a challenge where our goal with big data is to achieve what only a God could do, which is to predict and control outcomes. So with data, I wanted to increase our data literacy by understanding what's the difference between data, information, knowledge, wisdom, and the actual source, the source being the noumena in and of itself. So data being the first phenomena, this is just unorganized, it's just unorganized like stuff. That's all it is. Data can just be thought of like, oh, hey, this is a bunch of stuff. Like this is data. So too is this. It's fairly meaningless. However, when I label things, if I say this is a coffee cup and they put a coffee collar around the coffee cup so I don't burn my hand while I'm trying to drink it. This is an iPhone, right? It enables me to do X, Y, and Z. That's labeling, annotations. Then we have knowledge. Knowledge is when I say, okay, this is coffee. When I drink coffee, I get energy. That's knowledge. Now, wisdom is when we say, okay, well, I'm doing a 12-hour hackathon. Could I not eat during that hackathon and only drink coffee? Or is this a different type of energy that's only going to help me in some situations? So, although it is true to say that coffee is going to give me energy, when I apply that mental map into the wild, and if I tried for 12 hours to only go based on coffee, something bad would happen. So, so data would say, like, oh, hey, this is something. Information says this is coffee. Knowledge says that coffee gives you energy. But wisdom says that's just one part of a balanced diet. You're not getting all your energy from that. And sometimes the energy may not be good energy either. It may not be productive energy. Could be nervous energy. So that's the difference between data, information, knowledge, and wisdom. And so, just simply using my imagination, we're able to understand data better. And one of the reasons why is because large language models are neural networks. Neural networks are mapped just like your brain. So, that's another important thing worth keeping in mind. Okay. So, as we continue moving forward, what I will now do is I will tell you a little bit more about the hackathon over the weekend. So the hackathon was held by Builderbase, and Builderbase has tons of events. So I'll go to past, and so we'll see that this was the event, and so it was hosted by both Dell and NVIDIA, and the goal was to use local AI on a very particular type of hardware, the Dell Pro Max. And inside of that Dell Pro Max was a very special compute mechanism from NVIDIA called GB10 for Grace Blackwell 10. It's a reference to their newer architecture for training AI as well as getting AI inference. So that is the hackathon that I participated in, and so I won the top prize, winning that Dell Pro Max. And what I will now do is I will talk a little bit about what enabled that win. So the project that we submitted, this is available on GitHub. So I'll come over to GitHub. And we'll see right here. So we do see that this is NVIDIA GB10. So this is the project. And what I will do when you are examining a project, it is always good to take a look at the commit history. And we can see what work happened along the way. Now, it is important to review this. If you want to have a quick understanding, because it's a small list, you'd go bottom to top, actually. So the first thing was like we made a proof of concept. Then I enabled some scripting for general access. Then I started working on a concept. And so this is one of the top things that people are trying to do with AI, which is trying to create a digital twin. We'll talk about how that is trying to match phenomena to the noumena. And then I do a number of other tasks that are associated with winning the competition according to what the rules are. This repository, I highly recommend, kind of poking around through it, taking a look at the commit history. You can also see that there were a large number of issues that were filed inside of here. So this is extremely important because your agent context cannot hold all of this. So I will usually use GitHub issues as a simple mechanism for holding information and holding context at runtime for my coding agents. Additionally, you can see the pull requests that were made into the project, and you can see that there are a few things that are worth noting inside of here of which PRs managed to get merged in purple and what PRs ended up needing to be closed. I had a number of teammates who joined at the end, and I think this is probably a great place to come in. And now what I will do is I will say, how did we win the hackathon? So, how did we win the hackathon? Well, number one was establishing a clear leader and plan and not derailing. So, at the hackathon, one of the things that was problematic was that there were too many people at the hackathon. Builderbase told us that, these teams were only supposed to have 2 to 4 people. And the day of the competition, because they wanted to appeal to their sponsors, they inflated the team sizes to teams of 8. So we now have 320 people competing. Now, what I think is extremely important to say is that 8 people cannot split a prize, a single device. And so establishing a clear leader and a plan and not derailing. So one of the big issues was that we had other teammates, and you will see that their PRs were closed. This is extremely important because I see many times junior engineers are participating in hackathons, and they use it as their opportunity to learn from someone in the field. And what ends up happening is that as a result of me doing the hackathon with you, I probably never want to work with you again. And I would never recommend you. And so this gets into point number 2. So establishing a clear leader and plan and not derailing. And then number 2 is saying no to Claude Brain. And I'm going to get into what Claude Brain is, because the PRs that were submitted by my teammates who were added by Builderbase to my team, kind of very forcefully. I didn't fully consent. So the issue with the PRs that were closed was that all the work that the junior engineers who were added to the team later on hurt the team. So what I will now do is I will write over here, your work is hurting other people. So this is extremely important to remember as well. It's like, oh, people are just throwing shit together with Claude. But the big issue is that your work is actually hurting other people. You're hurting the plans of other people. And then number 3 is honor. Honor, respect, and duty. One of the big things that happened after we won, so the thing that I think is really important was, how was this team formed? So this team was originally formed to be like, the idea was bring your own startup. And so like Anthony and I are in America, Kazar's in Islamabad. So originally Anthony and I were like, okay, what could we do and who should we recruit? And so originally, when we were thinking about what should we do and who should we recruit, my immediate, both of us immediately wanted to work with one of our former coworkers, Rex Belgrade. And so, wow, that's like hilarious that I thought that was just like going to work. Oh wow, Rex has a hotel named after him. Okay, that's awesome. So we wanted to work amongst domain experts. And then we had a bunch of people who joined the team at the end. And as I mentioned, the big issue is that this whole code base, when you take a look at which PRs got merged in versus which PRs did not get merged in, the only PRs that made it were mine. All of the issues were filed by me, and all of the code is fully written by me. There's a single contributor. And so the reason I want to talk about honor, respect, and duty was that two things happened. When we won the competition, my friend Somya made a very small mistake. And what happened was that usually they will announce the winners as who won third place, who won second place, who won first place. And when Somya announced the second place winner, he accidentally also showed that we won. And so my teammates who didn't contribute started screaming, jumping down, and celebrating. And the other team that won second place, they lost their moment to celebrate. So that's honor, respect, and duty. Then the other thing which really bothered me was that the juniors who participated on the team immediately upon winning tried to get me to sell the Dell Pro Max GB10. And immediately I said, well, that is extremely poor taste. Like, this is exceptionally poor taste. Hold on. And I don't know why. I don't know if Dell's having an issue. Yeah, it looks like Dell was having an issue. But this laptop is worth quite a bit of money. There was a pretty big price drop on this. I'd probably say almost like 2,000 or $1,500 on this. Uh, but what I want to mention is that this is still a lot of money. And so the junior engineers on the team who did not do work, who obfuscated from the goal and hurt the goal, they wanted to immediately sell this. And so my third point on the key to success is that I operated with a sense of honor, respect, and duty. That the goal of this hackathon is because I'm interested in local AI, and that if I win, I'm going to do something in the ecosystem with this device. The junior engineers on my team are trying to, one, see if they can take the prize away from me. And then number two, see if I will give them free money as a result of this. And so, really what I would call this section is, this is going to be what not to do for junior engineers, because this was in such poor taste. And so Rex and I talked quite a bit throughout the whole hackathon. And one of the big issues is that, this is like a major what not to do. And what I'll also do is how I will categorize this is like, this is also really about emotional maturity and professionalism. And so given how my teammates kind of responded to that, I can tell you that this is why, even though we won, they would never get a recommendation from me or like continued cooperation, because this showed an immense lack of emotional maturity and no professionalism. This was just saying, hey, you worked all day. We want to take your work. We want to take your prize. And then we want you to continue doing more and more free stuff for me because I'm a junior and I need help. I have to tell you, this is probably one of the worst things that you can do as a junior engineer. So this was section one of like literally don't do stuff like this. In your hackathon, establish who a clear leader is and what the plan is. The entire time, the two juniors on the team kept mentioning bad idea after bad idea, and they kept derailing the work. As a result, none of their work made it to the end. And when you take a look at who the only contributor is to the code base, it would be me. Now, we knew this going in. We knew that, our game plan was going to be, as I mentioned before, Anthony and I were thinking about what problem space that we could solve, and then how could we bring in a real subject matter expert like Rex, who's a doctor, to work towards it. So Rex did a lot of steering, and then I did all of the coding work. So that was number one, was that we knew that this was the plan, and that when they would derail, I would just tell them, no, I'm not going to sit here and let you stonewall. right? So stonewalling was the big thing. So now what I will do is I will take the section of like, and I will repurpose the section of to be what not to do at the hackathon. So what not to do for junior engineers at hackathons. And so number one is derailing and stonewalling. Number two is Claude Brain. And so just having terrible, terrible PRs from Claude. You can't just think, oh, Claude wrote this, so now it's going to work. And because I have a master's degree, I magically know. Um, so this is where I have to say your work is hurting other people, and your work is hurting other people because you're constantly doing work, but you're not reviewing your own work. So what I will say here is it's the Claude Brain that I'm saying. This Claude Brain that I'm talking about, this is really like not reviewing your own work. So the big issue was that they were like, oh, look, I just asked Claude, like, let's take a look. So what I will now do is I will come back to the repository. Take a second to find the repo. Yeah. So what I will now do is we will go over why these PRs were closed. So these PR, so like let's take a look. This was a really bad PR, and the reason why this was a bad PR is this is a single commit, but let's take a look. This is 60 files that were changed. And then if I was to reason about, well, how does this change everything? You know, that's way too big of a PR. You never want to have a PR that big unless you have a strong constitution of this is how this works, as well as a lot of rapport with the other person. So what I will now do is I'm going to go over why this was a bad PR. Also, take a look at the description. The description adds no insights. The description actually, like, this is what I mean by Claude Brain. So if I read the first sentence out loud, add 10 synthetic patient bundles and a combined FHIR R4 collection. Okay, but what does that do? Does that actually do anything for the code base? And the answer is no. This does absolutely nothing for us. And why does this do absolutely nothing for us is that when I look at the code, what I can do is I can look at the code base and now I see, okay, this is a lot of JSON. But this, take a look, this is all synthetic data. When I come back to our model here on data, what I will see here is that, oh, so you have labeled data. However, when I see the labeled data, what I will immediately notice here is that, okay, so this is a schema. But this schema, notice how the schema has no IDs. The schema has, like, right, there needs to be some pattern for normalizing this. And there is a normalization structure inside of here, which will say, hey, how do I take the data and do that? However, does this matter? This is all fake data. And why would I add this to the bundle? How much would this increase the bundle size and hurt the performance of the application? Additionally, when it's time to review the code base, this does not help us whatsoever. This actually just creates a data folder and then puts random data inside of it. And so then again, you have to come back and say, all right, well, this is an example. This is an example of Claude Brain. You added a bunch of work, but you didn't bother reviewing it. And you didn't bother thinking about it. You didn't bother testing it in your head. You said, I did this. Let me throw this on your plate. And then let me keep bothering you until the work is reviewed. And so not only was this Claude Brain, but this was also stonewalling. This was stonewalling because we had an even better workload concept. Even though we won, we had a very strong mechanism for creating a digital twin voice clone. But the two juniors on the team kept complaining, kept doing bad ideas, and really put us on a pathway to be hurt on the team. And this is because there was a lot of stonewalling. And the stonewalling and the derailing occurred because, as I mentioned, this hackathon was only supposed to have a team of 2 to 4 people. So our idea was that it would be Anthony, myself, and Rex, and then we would find one person the day of that we would at least enjoy working with, who could try to fill a gap, and then we wouldn't have so much of a problem. So this is step one, was that derailing, stonewalling, bad ideas. Then number two, they didn't bother reviewing their work. Then number three is I did all of the work, all of the idea, and managed everything. Everyone else got a chance to go enjoy lunch. I didn't even get a chance to eat lunch. I fasted the whole day. And then when we won, they ruined Team Two's moment to accept their victory and to be recognized. And then additionally, they started bothering me after the competition, and they bothered me so much that I was not able to do effective networking after we won. The one of the juniors who did none of the work and was one of the big reasons why I even had to go to the competition organizers at one point and mention, like, no, this is really problematic right now. I'm really not enjoying this because this is a total lack of emotional maturity and professionalism. And so lacking honor, respect, and duty, and then trying to force me to sell this. And now we still have an issue at the end where with Builderbase, we're going to have a problem because I did all of the work, but there's a chance that I did all of the work, but I will not be able to reap my prize. So this is, it's really unfortunate. Um, but this section is extremely important. Like when you're a junior, when you're working with Claude Code, like derailing and stonewalling, this is really going to get in your way. Having Claude Brain, not reviewing your own work, and then again, just the basics of not having honor, respect, and duty for what it is that you've come here for. You've come here for competition. The competition specifically has a problem statement saying that we are going to create an always-on business agent, which is the goal of my curriculum. That's why I'm participating. Now, many people do want to have a good prize, but when you're only there for the prize and then you do something which is extremely distasteful like that, again, you can win the whole competition, but like, I know you now, and now I'm never going to work with you again. I'm never going to recommend you again. And I'm actually always going to try to find a way to actually get away from you. So this is an important section and a lot of times I will do this because, many times people do get confused. There's a quote from Charlie Munger, which I love, which is invert, always invert. You don't want to think about what you want. You want to think about what it is that you want to avoid. That was probably one of the biggest things that helped us win. Was I knew that because they were doing this very bad behavior, I knew that I could just kind of come into my own voice and say, all right, I know I don't want to be derailed. I know I don't want to review bad quality work from someone who's trying to effectively steal from me. And then I also know that my friend Soumya Gupta is hosting this hackathon. Giving my friend Soumya and his network honor, respect, and duty is what's going to help me. Whether this prize is unrightfully given to someone else is fine by me because I know I won and it was announced that I won. Now it's just a matter of the prize. So now that we've gone through this section, the next thing that I will now talk about is continuing data literacy. Now, data literacy was covered yesterday. If you do need to see the previous lectures in this series, you can just go to thepromptclinic.com. When you go to thepromptclinic.com, all of these live streams are organized in this left-hand side panel. And you will see that each of these, like, this is a really good one for juniors who if you think your brain is rotting because of Claude, um, you'll be able to watch previous lectures. Timestamps will be here along with the exercises that I'm recommending you to do, because many times it is important to have an accessory document alongside of you. Lovely. So now the next step is going to be talking about, like, okay, how do you put this into a coding agent? Like, how do you design this? And so when we work with a coding agent, I'm going to keep this on the screen just because, like, I do think that this is important. And I mean, I'm also still, I did all of the work, and now I have to constantly think about someone trying to steal my prize. So what I will now do is I'm going to talk about instrumenting your coding agent. So when it's time to instrument our coding agent, how is our coding agent going to work? What is our coding agent actually going to do? And so our agent actually comes from an economic principle. And so your agent has some incentive, and based on, kind of trying to get that incentive, they apply reasoning, which is why I brought up Immanuel Kant, plus actions to achieve an incentive. That is what our agent is trying to do. It has some reasoning, which is given to it by an LLM. And so now I want to provide some annotation. So reasoning, this is the LLM. This is the intelligence layer. But then the actions, this is software. That's the software layer. And so what this is skills and tools. And so that if I give an LLM skills and tools, and then I'm going to wrap this. Okay. If I now wrap this into, yikes. This shape, I think, is going to be a little harder to do than I thought, which is fine. I wasn't expecting that. But now I'm going to wrap this into something called a loop. And that's why people are calling this loop engineering, quite simply, is that really this is wrapping reasoning and actioning until this incentive is achieved. So the loop then stops when the incentive is achieved. And this is how a basic for loop in programming works. And so in actuality, your coding agent is really just saying, while goal is not true, do, and then a sequence of reasoning, acting, validating. And then it will continue to go through that process of, while my goal is not true, I am going to reason, then I'm going to act, then I'm going to validate, then I'm going to reason, then I'm going to act, then I'm going to validate. And then when the goal does get achieved, the goal state will then move to true, and then we break out of the loop. And now the agent's job is done. And then you can continue asking the agent to do more things. And so this is one of the best things, because now this is telling the human, hey, you could take these things off your plate. So this is the simple mechanism for working with your agent. But if it's this simple, why did so many teams fail? And I want to come back to this because, this is still actually bothering me right now. And so what I will now do is I will come back and say, well, if it's this simple, why why did something very unique happen? So 40 teams, only 7 selected. So originally in the hackathon, they said that the top 8 teams would then get a chance to demo. So the top 8 teams would get a chance to demo, and that the 4th to 8th place teams would get some swag. But what happened was that so many people, so many juniors did not follow the rules. Therefore, only 7 teams made it. And the reason why was that the goal for the hackathon was that you must use local AI. Many people did not use local AI in their agent's runtime because they had no difference between what runs on the machine and what happens in the cloud. Number 2 was that the goal for the hackathon was to have an always on business agent. Always on. Their applications were just like, no, this is a cool idea. This is a cool idea. And so as a result, they derailed and stonewalled. Many teams another big issue many teams had was that on Dell Pro Max, they were not able to download Claude code effectively to the host machine. Whoa, wait. What do you mean they weren't able to get Claude? And in this is what we'll do is we'll now come to the docs for Anthropic. So we'll go to Anthropic's website and we'll see if we can find Claude code. And what we'll now do is this is available for look. This is happening on operating systems. This Dell Pro Max is using Linux. This is where many people failed. Even though they know software engineering, they only know basic stuff of how to stitch shit together, literal dog shit. And so this is a problem. And this is a problem because if you're constantly just stitching together dog shit and you don't know how to use the command line, the command line is accessed through a terminal. And so the terminal, this is what a terminal looks like. And your terminal is not just running Claude code inside of the terminal, but it's also running commands. And that is the core tool your agent has access to is bash scripting and Unix tooling. So we will now briefly look at what that is. I will now come to Google and let's take a look at what is Unix. So Unix tools are small modular command line programs designed to do one thing well. And so a lot of teams will usually go to Claude, say, win me the hackathon, make no mistakes. But if this is your tool is a Unix tool, and it's designed to only do one thing well, and that really it's going to do the following things. It's going to do file management, text processing, system and stream control. Are you going to be able to make a complex, ambitious application with only small modular tools? And the answer is no. We then have to package up small modular tools into components that are all distinguished by a boundary, and then connect those together using an architectural pattern like model view controller. So this was a peak example of Claude Brain. Many teams were not able to work on the machine. Despite being software engineers, they do not have the ability to type effectively anymore. By not having the ability to type effectively, they are not able to use bash tooling and Unix tooling that would give them the ability to work hand to hand with their agent. Because in your loop, we have reasoning, acting, and validating. The human constantly has to do validating. And then that validating updates the reasoning and then the acting. However, when you're the human in the loop and you have a short amount of time, you also must do the acting, as well as you must distill and document proper reasoning. Many people did this quite lazily because many people join hackathon teams to do no work because they have no plan for the weekend, and then they want to take credit for someone else's work, which again, like, I'm not letting that go, right? You can't take credit for someone else's work. You got to be real about what your accomplishments are, because it is extremely, I think it's beyond wrong to take someone else's work and claim it as your own and then just be burdensome. Okay. So, what I will now do is, this is how our coding agent was designed. This is how everyone's coding agent should work. So now, how did we overcome the biggest problem of the hackathon, where we had a large, we had more than half the team, which is derailing and stonewalling? It's through leadership. Through the leadership that I put in place, what I decided to do was, we had a real doctor on the team, Rex, my good friend. And so we just focused on steering our AI. So for setting the goal was set by our subject matter expert. The reasoning was also set by our subject matter expert. And then, because I actually know how to use the command line, I was able to act alongside of a coding agent. And because I knew what we were doing, I would do a lot of the validation and then I would bring it over to Rex at specific intervals. So I didn't stop Rex from doing the core job of reasoning, as well as doing the core job of, like, looking at everything that's going on and being able to say, well, is the goal still correct? Do I need to update the goal, update the path? And so, just by our friendship and our imagination, we were able to beat all of the other teams, because with friendship, imagination, simple systems, and following the rules, well, it turned out that many teams didn't follow the rules. A lot of the top 7 teams also didn't follow the rules either. So then our probability for winning just shot through the roof, because the other teams did not bother thinking. All right, so I think that's enough for today's kind of like walkthrough of how this worked. And what you really got out of today's session was, this is the core pattern and foundation for how coding agents work. Is that coding agents is just an LLM inside of a for loop, but the LLM has access to software. This software specifically is referred to as skills and tools. Now, additionally, we can have other things that help with performance, such as memory. And this is particularly important because of context and context windows. Like, this is a constraint-based limitation pattern. So as a result of this, we can then say, well, if we steer our AI with the human in the loop into the correct goal, and if we just align on what is the goal, being the incentive, if I align the goal with the incentive of the competition, matched by a true subject matter expert, and then that subject matter expert is also responsible for reasoning with me until we reach an alignment, then my job as a software engineer is, I will direct a coding agent and multiple coding agents on how to act. And in addition to acting, I will program the skills and tools that will be needed by the agent's runtime. Okay. And then I will also be responsible for validating everything. I will read the code. Now, this is really important because another one of our junior teammates at the end of the hackathon submitted a PR that would have jeopardized our entire demo. So what this junior did was, he had he had a bad attitude because none of his work was being recognized because he just wasn't even bothering to think beforehand. And the big problem here was that, you know, the big problem with his work was that it included a timeout. And that timeout would have caused a timeout, like a time-based problem, which would have caused our demo to exit early. And I mean, I had to go read the code and resolve this one thing. But keep in mind, like, what did the PR say that it did? And did he even bother? He did not write this PR. This PR makes no sense to me. Again, look, written by Claude Code. So this is Claude Brain in full effect here. The Claude Brain is not reviewing your own work and having your work hurt other people. So by having a good division of responsibility with Rex, where I was like, all right, Rex, like these are the rules of the competition. You and I will talk about what the goal is. We'll ensure that the reasoning is correct. That reasoning will then be encapsulated predominantly inside of our repository. However, it's not going to be able to have everything. And then many times other people still, even though the code base has everything you need, their coding agent isn't set up like yours. And so you can have big, crazy problems like that, which could really kill you at the end. Um, and then, of course, we have the validation loop, which is saying, well, did we get to the goal? Why did we not get to the goal? And that comes from being able to label data effectively by not just using Claude stupidly, but to go through the process of what I showed you, where we will go. And I was doing this previously yesterday, but where I would be able to just go in and start annotating and then cluster my annotations together. So that is the concept. That was from yesterday's stream. So this concludes today's stream, where the goal of today's stream was to talk a little bit more on a live case study about data literacy and how to put these concepts together for a real world prize for something which truly does matter. Winning the NVIDIA Hackathon is a very big deal. It's something that definitely helps me signal to other people that I'm one of the top developers in the entire New York metro area, and that my skills go beyond being a full stack software engineer. My skill set is that I can just on a Saturday roll up my sleeves and write CUDA kernels, even though that's not my specialty. And I can also do that for a competition for the hardest areas of where NVIDIA itself is looking for more AI use cases. So I will do another update on the hackathon. I will first wait to get pictures from the hackathon. I am planning to submit the victory to a few media outlets for coverage, as well as I will follow up and I will find out if I rightfully receive the prize or whether this is going to be something that is taken from me and I'm forced to unfairly compromise. So we'll find out. Stay tuned for the rest of the week, and I will.